Alright, yeah, this is Sapo Code. I'm going to be dropping this video based on the wave general equation. Man, I like my L. Alright, let's get to it. Alright, you can see this is the wave general equation, and first thing first, let me I actually had this. Let me go with this one first, then I'll come back to the first one. Now, from here, we have that if you check your textbook very well, it said y is equals to a sine 2 pi over lambda open bracket x plus or minus vt. That's the equation. Then you can see that the 2 pi over lambda is outside. The first thing you have to do is to open bracket with 2 pi over lambda, which now give us y equals to a sine 2 pi x over lambda plus or minus 2 pi vt over lambda, where v is equals to f lambda. We have that y is equals to a sine open bracket 2 pi x over lambda plus or minus 2 pi f lambda t over lambda. All we did was to replace this v that is here, which is equals to f lambda, and put it in this place. And then at the end of the day, lambda will take out lambda. You have that. We now have that y is equals to a sine 2 pi x over lambda plus or minus 2 pi ft. Now we also know that omega is this that angular velocity sign. Omega is equal to 2 pi f, and also phi or theta. I'm using theta in your textbook. Is phi though. Phi is like it's like this. So they use phi, but let me use theta. So we know that theta is equals to 2 pi x over lambda, which is also known as the wave number. Then you have that y is equals to a sine open bracket theta plus or minus omega t. What I did was just to replace this guy with theta and replace 2 pi f with omega, and this is also a wave equation. Note all equations here, they are important. Now if you are confused, I'll take you to this other part again. Now in this part, I have that you see the omega t that you saw here just now. 5 plus omega theta plus omega plus or minus omega t. I now brought the omega t forward plus or minus theta. Note any of these things can come. Theta can come to the front, phi can come to the front, omega t can go to the other side. You get, it can happen interchangeably, so don't be confused by it. Now I just have that is what I have here is what I also have in this page, but what I now did was to let you know that you can interchange them any way deem fit. Now one other formula, I don't know if I wrote it there. You have that if you have this, omega is 2 pi f, theta is 2 pi x over lambda. Just replace. You have this. This is another wave equation, very important. Then you now have that f is equals to 1 over t, which is normally frequency is equals to 1 over period. So if frequency is equals to 1 over period, replace frequency in this place, you get this. And when you get this, this is another wave equation, which is important. Yes, if you introduce a velocity into the equation, that's the one we started with first from the equation, you see that we have that a is equals to a sine, y is equals to a sine 2 pi vt over lambda plus or minus 2 pi x over lambda, which will give us this final equation. At the end of the day, if you check everything here, it's something like what we have in the other page. I just have to rewrite them. Now, and I have a question to help buttress this point. They said in the equation a y equals to 5 sine 3x minus 4t. Yes, 3x minus 4t, where y is in millimeters, x is in meters, and t in seconds, represents the wave motion. Determine. They said this equation you are seeing here represent the wave motion. They now ask you to determine the amplitude, the frequency, the period, the speed of the wave, the angular velocity, the wave number at x equals to 3, and also the wavelength. So step by step, this is the wave equation. All you have to do is to compare this wave equation with the general equations that is available. Now if I compare this wave equation with this one, which is one of the first equation, I've already found my amplitude. Amplitude is where you have a, you have 5. Are you seeing that now? Just get my amplitude straight up, and that's all. Then if you go to the frequency part, they say we should find frequency. Compare the same wave equation with this one, with any of the general equation. I'm choosing this one now. I have y equals to a sine this. Now if you check, this side have a t and this side have an x. 3x is here, 40 is here. So what I did, I compared the 40. You compare these things without being ignoring the sign. Don't bother about the sign. Then you have 40 2 pi x, 2 pi ft. T cancel out t, make f subject of the formula by doing some cross multiplication, dividing both sides. You get that f is equals to 2 over pi hertz, which is equals to 0.6366 hertz. Use your calculator to get that. You see the final answer. Then you now have the period of the wave. The period of the wave is equal to, and now I'm comparing this. Normally I can just say f is equals to 1 over t. You get that would be straight up answer, which is correct. If I divide this thing, if I take the reciprocal of this thing, that's 2 over pi, I will get pi over 2. But let me go through the hard way and getting it done. The hard way is I'll compare it again. I will say I'll use the other side. I have t. 4t equals to 2 pi t over big T. Are you using that now? T cancel out t, cross multiply, divide both sides. You have that t is equals to 2 pi over 2, which is also a long process. That's 1.57 seconds. Note this one is just the long way. You can just do 1 over f and you get your answer correctly, since you have already found the frequency. And let's go for the wavelength. The wavelength is y equals to a sine 2 pi this 2 pi ft plus or minus this. Now if you see, I'm comparing it now with the other part of the equation. So I'm taking 3x from here, from the question that was given to me. I'm comparing it with 2 pi x over lambda. Now if I do that here, 3x equals 2 pi x over lambda. You know 3x equals over 1. So x will take out x, cross multiply. You have 3 lambda equals to 2 pi. Divide both sides by 3. You have lambda equals to 2 pi by 3, which is 2.09 meters. Remember they said lambda is the wavelength, which is also measured in meters, right? Now remember, what is wavelength? Wavelength is the distance between two successive crests or two successive troughs in a wave. Then if you go to the speed of a wave is equals to v, is v equals to f lambda. V is already there. F, we have found f before. We just found lambda. Now all you have to do is to put it into the equation. Just multiply it together. If you multiply, you get 4 over 3, which is 1.33 meters per second. Then if you do the next part says you should find the angular frequency. Angular velocity. Angular velocity is omega equals to 2 pi f. We already have 2 pi f. So we already have f, which is frequency. So if you have 2 pi times 2 over pi, you have 2 pi will cancel out pi, you have 4 radian per second. Now if you note what is going on here, if you compare it with the general equation self, like you can see this equation, compare it with this one, you'll be having that where you have 4t, you have omega t. If you say 4t equals to omega t will cancel out t, omega is t equals to 4. Are you seeing that now? Just compare. That's how easy wave equation is. And if you go to the final question, which is the wave number, the wave number is it said calculate the wave number at x equals to 3. Just omega theta is equals to, or phi is equals to 2 pi x over lambda. X is given, lambda you have found. Just do your calculation. This, if you do this now, 3 will swap up to the top, and then you have this, which cancel. At the end of the day, you have 9. That's how to calculate wave equations. Very simple, very swift. Do this for all possible questions given to you in wave. Your answers will just pop out easily. Compare. Life is good. Thank you very much.